Let's look at example 2. Janet Reed would like to know if there is any significant difference in the mean number of hours worked per week for the department managers at her 3 manufacturing plants in Buffalo, Pittsburgh, and Detroit. I want us to test this using an F-test, a Fisher test, and an ANOVA test, and it will be conducted using alpha equals 5%. So for this question, we can look at what is the factor. What is the factor that can bring about change? We'd like to know if there's any significant difference in the average number of hours worked per week for the department managers at her 3 manufacturing plants. So the thing that can bring about change is the 3 manufacturing plants. So the factor is manufacturing plant. That's the main factor that can bring about change. The treatments or the levels is just a number of factors, which is 3, and it's Buffalo, Pittsburgh, and Detroit. The experimental units, what are we experimenting on? Well, we're experimenting on the managers. And the response variable, what are we actually going to record is the number of hours worked by those managers. So let's have a look on the next page. If we look over, that's explained here. So that's explained to us right there. What the factor is, what the treatments are, what the experimental units are, and what the response variable is as well. So I've actually put this information that we're going to see right here. I've put it into Excel. But before we move on, I'm just going to quickly click to the next slide. And the next slide is telling us that we want to check to see if the averages are the same or not the same. So you can see that the hypothesis for ANOVA is always the same. The means are equal, they're not equal. But it's good to know what the means actually represent. So mu1 is the mean number of hours worked per week by the managers at plant 1, and then similarly for plant 2 and similarly for plant 3. So if we do not reject the null hypothesis, if that turns out to be our conclusion, that would mean that the average number of hours worked at plant 1 and plant 2 and plant 3 are all the same. Otherwise, they're not all the same. So that's what we'd like to check. So I'm just going to go over to Excel where I've read that data in. So, well, it's going to be fairly straightforward to do. We're going to hit Data and then Data Analysis. And we need ANOVA single factor. Press OK, the very thing at the top. And we're going to highlight our data, which is this is the data I've got. Remember not to highlight for single factor ANOVA, which we're looking at so far. That's all we've looked at so far. Do not highlight that first column. Because I've included Buffalo, Pittsburgh, and Detroit as labels, make sure labels is clicked. Alpha was indeed 5% for this question. And let's put the alpha range in F1. Is that a good spot? F1, yeah, F1 is right there. Oh, see, I just changed the input. Be careful not to do that. Excel's a bit, it's a bit quirky, so make sure when you're changing a figure, you're actually changing the figure that you think the range that you actually believe you are, because sometimes Excel pops around with the cursor. So I want the output to be F1. There you go. So press OK, and there we have all the answers. What we can do before we move on is we can recreate all those answers as we did on the previous example, or we can just get on and solve the problem. Okay, so the problem we're looking at is we want to check to see if the average for plant 1, which is the average hours worked. I think it was Buffalo, plant 1, yeah, Buffalo. The average number of hours worked per week by the managers at plant 1 are equal to the average for plant 2, which was in Pittsburgh, is equal to the average for Detroit. That's going to be your null hypothesis, H0. your alternative is not all the same, that they're not all the same. Alternative not all the same. And we're going to get always for this ANOVA, always for these ANOVA questions, we're going to get a one-tail test. And the rejection region is always going to be over to the right. This is assuming we're going to use the critical value approach. So let's put critical value here. This is the critical value approach. And we're going to get a do not reject region always will be to the left. This is your do not reject H0 region. And then we're going to get our reject region over to the right. And all we need to complete this is to pick out the critical value. So the critical value is this value here. It's 3.88. So we can put in the critical value as 3.88. And then we can put in the test statistic, see where that falls. Oh, 9. Well, it's going to be way over here. 9 is going to be way over there. So the conclusion is reject H0. So this is rejecting H0 and going with the alternatives. This is suggesting that the average number of hours worked at the different plants are not the same. If we actually look at the average for each plant, these are the averages, and you can see that plant 1 and plant 2 are relatively similar, but plant 3 looks very different. So that's the result we get using the critical value approach. And now we can just use the p-value approach. Remember, the p-value approach says that if alpha is greater than or equal to the p-value, then you reject H0. Otherwise, if alpha is not greater than the p-value, then you do not reject H0. So what is alpha? Alpha is 5%. Where's the p-value? P-value is a very small number. It's not even 1%. If you're not sure of what that number is, click on it and change the formatting. So that implies that we should reject H0 again, so we get the same result. So what we can do is we can come down here. If you weren't sure about this p-value, just click on it and make it into a percentage up here, and it's about 0%. You can add a couple more decimal places, so it's 0.3%, as I actually wrote down here. If you're not sure about it, you can actually just use the formatting up here to figure that out. And if we actually start off, so I'll copy this, I'll copy some of these numbers, copy this, and I should copy this as well. Oops. Just copy these, put them into there, and let's see. So if we have the 490 from above, so this number in here, I'm just putting it into here. And if we have the 308 from above, can we fill in the rest of the numbers? Well, this number, the total, is just going to be the sum of those, the previous ones above. So that's going to be equals, well, just say that, plus that. We could have just done sum. And what are the degrees of freedom? Well, for this question, remember the degrees of freedom for the between groups is the number of treatments minus 1. So the number of treatments, the number of levels of the factor is 3. So 3 minus 1 is 2. So that's where the 2 comes from. And the within groups degrees of freedom are the total number of observations, okay, which is 1, 2, 3, 4, 5. 5 3 is 15 observations minus the number of treatments. So 15 minus 3 is 12. How do I get the mean? The mean? Well, the mean is just going to be this number divided by this number. So the mean is going to be 490 divided by 2. And the mean, we're matching up what's coming up above, and the mean here is just going to be the 308 divided by 12. And then the test statistic is going to be the division of these two. So it's going to be equal to this divided by this. That's going to give us the number above again. And for the p-value, we're going to use equals f dot dist dot right. And we need the x, and the x is just the test statistic that we put in there. And then we put degrees of freedom 1, which are 2. You can either type them in or 2, or you can hard code them, or you can cell reference them like I am right here. And that's given us that figure up here. I changed the formatting here, but it's the same figure. And the f critical value is going to be equal to f dot inverse dot right. And alpha to the right, we were told it's going to be 5%. This area to the right over here, 0.05. That's the significance level probability of making the type 1 error. And then we can put the degrees of freedom in. This time I'm going to hard code them as 2 and 12. It doesn't make a difference to the way your answer comes out. And we get our critical point. So we've reproduced the table. So these questions are actually very quick to do. And you just need to do quite a few examples to get used to doing them.